if we were looking at this diagram of the unknot over on the left, what we could say is that this is a diagram of the unknot, because in order to get the completely unknotted diagram, we would have to do first a type 3 move, the slide move, right? Slide this arc over to the other side of this crossing, and then we would get this 3 crossing diagram from over here. And then we would just need to do 3 type 1 moves. Type 1, type 1, type 1. That would untwist these little twists over here and give me the completely unknotted diagram. So we know this is a diagram of an unknot because there is a sequence of Reidemeister moves that takes me from this diagram to the diagram which I know represents the unknot because it has no crossings at all. I mentioned this was a computationally challenging problem, and one of the ways of quantifying that, this is actually a result that came out in 2015, so not that long ago. It was proven that if you hand me any diagram of the unknot, if that diagram has n crossings in it, then there exists an algorithm to unknot that diagram that consists of, at most, 236n raised to the 11th power Reidemeister moves. So that is a ton of moves. So if you give me, I don't know, you give me a 10 crossing diagram and tell me this is the unknot, it might take me, oh gosh, 236 times 10 raised to the 11th power. Let me just get a bound on that. 10 to the power 37 Reidemeister moves might be necessary to take me from the 10 crossing diagram of the unknot down to the totally uncrossed diagram of the unknot. So it's a bound, it's a polynomial bound, which is way better than a lot of these kinds of bounds in numerical analysis. But still, the more crossings that you add, the more out of hand the number of Reidemeister moves that it might take to completely unknot that diagram can get. But at least it's possible. Pure mathematician might look at this and say, oh, great, that means that it's possible. But an applied mathematician or a computer scientist might look at that and say, practically speaking, I'm not going to be able to program a computer to do arbitrarily large unknottings for you because the number of operations that it might take gets really big really fast. We can thank Mark Lackenby for the proof of this polynomial bound just a handful of years ago.